In this video, we're going to talk about solving exponential equations without the need for logarithms. And so these are just equations that are very simple to do. And so two objectives that we'll cover today are solving exponential equations with the same bases and solving exponential equations with the different bases. But in these cases, even if you have different bases, we can actually use simple techniques without the need for logarithms. So let's get started. Now, the one-to-one property of exponents states the following. If a to the m is equal to a to the n power, assuming that a are the same bases, right? Then we can say that m equals n. Or in short, set the exponents equal to each other. In example 1, we're going to solve the following exponential equation. 2 to the x power equals 2 to the 6th. So first, let's reiterate the one-to-one property, which is a to the m equals a to the n, then m equals n, right? So if we look at the bases, they're both 2's, right? So we can just look at the exponents, x and 6, and set them equal to each other to get our final answer. X equals 6. Our second example is a little bit tricky, but it's almost, doable. Actually, it is doable. 2 to the x plus 7 power is equal to 32. And once again, let's reiterate the one-to-one property. A to the m power equals a to the n. And if that's true, then m has to equal n. Now, in this problem, you see that there's a base 2 on the left and a base 32. So how do we get that 32 to be a base 2? Well, it turns out that there is 2 to some power that gives us 32, and that would be 2 to the 5th, right? So we can rewrite this as 2 to the x plus 7 power equals 2 to the 5th. And since they have same bases, we just set them equal to each other, the exponents, right? X plus 7 equals 5. And using algebra, we can just subtract 7 from both sides, and we would get x equals negative 2 as our final answer. Now in example 3, a little bit more challenging, still doable. 2 to the 2x power equals 1 over 16. Well, we see that there's a 2 on the left side, a base 2, and we know that 1 over 16, there's a way to turn it into base 2, but we're going to do it step by step. Well, first, what I'm going to do is I'm going to rewrite it as 2 to the 2x equals 1 over 2 to the 4th power, and that's because 16 is 2 to the 4th, right? Now, the next step is a little bit trickier, but it's 2 to the 2x equals 2 to the negative 4th power. And the reason we can do that is because we have a formula, right? 1 over a to the m equals a to the negative m, which is a property of negative exponents, right? Now, since the bases are equal to each other, we say 2x equals negative 4 and divide both sides by 2, which gives us x equals negative 2. Our last example, both bases are different. We have a 4 to the x plus 3 equals 32. First things first, if we look at the bases, the left side has a base of 4 and the right side has a base of 32. So the question that arises is, what is a base that 4 and 32 share? Or in other words, what number to what power gives you 4, and similarly, what is that same number raised to some power which gives you 32? I know, that sounds like a mouthful, right? But they both share a base of 2. And just to reiterate below here, it's going to show that 2 to the 2nd power is equal to 4, and likewise that same number 2 to the 5th power is equal to 32. So our next step is to replace the 4 and the 32 with the 2 squared and the 2 to the 5th as follows. 2 to the 2nd times the quantity of x plus 3 equals 2 to the 5th. Now, before I move on any further, let me just reiterate the previous part. Where we did the 4 and turned it into 2 squared, we're taking 2 to the 2nd power, but we have to multiply that 2 by the entire x plus 3 exponent. So just to clarify, if your exponent is a binomial or trinomial, you would do that 2. So in this case, it's a binomial. It would be 2 raised to the 2 times x plus 3. And on the right side, it's just a standard 5. And since the bases are already equal to each other, then we can set the exponents equal to each other. So 2 times the quantity of x plus 3 is equal to 5. Then the next step just uses algebra. So remember that the 2 times the quantity of x plus 3, we can use the distributive property to bring the 2 to the x and 2 to the 3, which gives us 2x plus 6 equals 5. And the next step would then be to subtract 6 from both sides, which would give us 2x equals negative 1. And then we can divide both sides by 2 to give us x equals negative 1/2. So this video, just to summarize again, it's just solving exponential equations without logarithms. So everything we did was just using one-to-one property of exponents, and we may have changed the bases on a few problems just to ensure that they get the same bases to make their exponents equal to each other. So hopefully you enjoyed this video,